We already know that a conductor through which current is flowing produces a magnetic field. In this session, we will study more about the magnetic effect of a straight conductor. Now, if we want to know more about the magnetic field that is being produced, we need to visualize it, right? And how do we do that? Yes, using magnetic field lines. Consider a straight wire with a current I passing through it. We already know that this wire will produce a magnetic field. To visualize the field lines, let's insert the conductor through a cardboard and sprinkle some iron filings on the cardboard around this conductor. Tap the cardboard a bit. You will see that these iron filings get arranged in a very particular arrangement, like concentric circles around the conductor. This is how the magnetic field looks for a straight conductor. A magnetic field has a magnitude and direction both. I hope you remember that. Let us talk about the magnitude later. But what is the direction of the field? How do we find it? Yes, we can use a compass. Just place the compass on one of these field lines. It will point to the direction of the magnetic force or the tangent at that point. If we do this for more points on this line, we will get the direction at all these points. So this will be the direction of the field. This leads us to a different problem. Do we need to carry the compass everywhere we go? That would be very impractical. Then, how will we find the direction of the field without the compass? To solve this problem, scientists came up with something called the right-hand thumb rule. Imagine that we are holding this current-carrying wire with our right hand in such a way that the thumb is positioning in the direction of the current. Then the direction of the four fingers shows the direction of the magnetic field around the wire. Now, let's talk about the magnitude. Obviously, the field close to the conductor is strong, but the field away from the conductor is weak. We can verify this by looking at the number of field lines. The field lines are dense near the conductor and become rare as we go away from the conductor, which means as we go away from the conductor, magnetic field strength decreases. Experimentally, it was found that strength of magnetic field is inversely proportional to distance from the conductor. All of this was about the magnetic field when the current in the conductor is constant. What happens when the current changes in magnitude and direction? First, let's look at what happens when the direction is changed. So far, the direction of current was in this direction. Now, let us reverse it. Quickly use the right-hand rule and find the direction of the field. Yes, this will be the direction of the field. Okay, now let's try changing the magnitude of current. According to you, by changing the current magnitude, what will change? The strength of the field or the direction? Yes, the strength will change. We can use a compass to find out. As we increase the strength of the field, the deflection of the needle increases. That is, the strength of the field increases with the magnitude of current. That's all for today. Let's quickly recap what we have learned. A current-carrying conductor produces a magnetic field around it in the form of concentric circles. And the direction of the magnetic field is given by the right-hand thumb rule, which states that if we stretch the thumb along the direction of current, then the fingers show the direction of magnetic field lines. The strength of the magnetic field is inversely related to the distance from the conductor. The direction of the magnetic field gets reversed if the direction of current is reversed. And we can increase or decrease the strength of the magnetic field by increasing or decreasing the strength of the current through the conductor. Hope you got to learn some new and interesting things.